Graphing polynomials, part 2. This time I'm going to talk about zeros and multiplicity and y-intercept. Second step of being able to graph a polynomial is finding zeros and multiplicity. Now, we spoke previously in last section about what is zeros and multiplicity. And I have an equation that's already in its factored format. Okay? And we would pull this out, set each one equal to 0, solve, and then declare its multiplicity. But what if it's not? What if it's not already factored? With this one, it's going to be a little harder. How would we solve this one? Well, in this class, we're not going to be. We would do something called synthetic division. Okay? And how does synthetic division work is we take factors and we only worry about coefficients. That's not something we are going to worry about. So, how do we find factors? Well, when it's not in its factored format, think back to your strategies of factoring. Okay? If it's 4 terms, we group. Three terms, we have the what? AC method. We have completing the square. We have quadratic formula. Those are for if it's x squares, because a lot of times it is. But what if it's not? It's only 3 terms. Well, then we better hope that we have a GCF, which if it's only 3 terms, I guarantee we do. Bet you anything. Okay? So, brush up on your factoring skills, because you're going to be probably doing several of this with your homework and these. But looking at a lot of your homework, I hate to tell you this, a lot of it's already factored for you. Several it's in this type format. So, this is in our factored format, so we need to find our zeros. Take each one out, like in the previous section, set each one equal to 0, and solve. I'm going to add 1, so x equals 1. I have a multiplicity of 2. So, now you notice I've got a format here. The answer is 1, 0. This is what I'm looking for because these are points on a graph. All right, subtract 1. So x equals -1. Power is 1. So I have -1, 0. Multiplicity 1. Subtract 2. X equals -2. The point is -2, 0. Multiplicity 1. Now, why am I declaring multiplicity? Again, even multiplicity crosses, odd multiplicity touches. Even, cross, odd, touch. This is what I want. This is what we need to... I said it backwards again. Even touches, odd crosses. I have no idea why I keep saying that backwards tonight. I apologize. Even touches, odd crosses. So, even, touch, odd, cross. Odd, cross. All right. Third thing we need is the y-intercept. Its format needs to be 0, the number. It does not have a multiplicity. You will always only cross the y-intercept once. Now, how do you get this? Look at only the tails. If you're in this format, but guess what? If we're in this format, it's very easy. Plug a 0 in for every x. So 0 to the 4th power is still 0. 0 to the 3rd power is still 0. 0 squared is still 0 times 3 is still 0. Negative 0 is still 0, so we have 0 plus 0 minus 0 minus 0 is 0, plus 1 is 1. So my y-intercept is 0, 1. If for some reason we did not have this, let's look at if we only had this format. Plug in a 0 for every x. And you have 0 minus 1 squared, 0 plus 1 times 0 plus 2. This is the other way of working it. Well, 0 minus 1 gives you -1 squared times 1 times 2. Well, what is -1 squared? That's the same as -1 times -1, which is 1, times 1 times 2. You know what? I wrote that equation wrong. I apologize. You can tell I'm tired. 1 times 1 times 2 is 2. So the y-intercept, well, I plugged in 0 for x, and my answer was 2. Okay? Apologize, I wrote the equation wrong when I copied it over from the previous page. Or did I write it on the previous page wrong? I sure did. That's why. So, we have our intercepts, we have our zeros, and our multiplicity. And again, even multiplicity we cross, even multiplicity we touch, odd multiplicity we cross. Even, touch, odd, cross. Right? Hopefully this is clear. We'll come back for the last bit.